In this video, we're going to learn how to identify congruent figures. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. So take triangles, for example. All the sides have to be congruent to their corresponding sides, and all the angles have to be congruent to their corresponding angles. So take these two angles, for example, these two triangles, for example. These two angles are congruent, and these two angles are congruent, and these two angles are congruent. So three pairs of congruent angles. However, look what happens to my sides. This black side versus this blue side here. Obviously, the black one is shorter than the blue one. They're not congruent. Therefore, these two triangles are not congruent. Okay, so that's what that definition means. Let's look at this example here. It's asking us to write all the congruent pairs of corresponding parts out. When we're given diagrams like that, it's much easier if we turn the diagram around, turn one of the diagrams around, so that they're visually easier for us to observe. And if I look at the revised pair, I would have the right angles A and angle F. I would have B and angle G, and angle C and angle H. Those are my three pairs, and they are all congruent. Okay? Now, let's look at the sides. I have AC corresponding to HF. I have BC is corresponding to HG. I have AB is corresponding to FG. And they are congruent as well according to this diagram because of these little tickers on the sides. So that's it. Three sides and three angles are all congruent to their corresponding pairs. Okay, so polygon QRST is congruent to polygon WXYZ. For this one, take a minute that you'll see that we not only have to rotate the bottom side, x, y, to the top in order for us to match the top diagram, we also have to rotate the left side to the right side. So if we do that, if I rotate the bottom to the top, I would have yx. Now if I switch sides, I would have xy, and then therefore I would have w, Z at the bottom. Let me write that down a little lower so that I have enough space. So I said WC. And if I do that, I should have something like that. That matches a little smaller than that to match up the graph on top. Let me erase the ones that I don't need. See if it makes sense. Okay, so I'll redraw this here on the side. And now if I have my matching sides and matching angles, now I can see that my angle Q and angle W are congruent. So angle Q and W are congruent. Q is 65 degrees and W is 5x plus 5. And if you do your math, you should be able to find x is 12, right? And then same thing with the sides. The side WX is y minus x. And then its corresponding part is 6 inches, which is RQ. We know x is 12, so y has to be 18. Okay? Next example, this one is a little easier. We just need to rotate this sideways from left to right, and the easiest thing to do is for the right angle to match up. There we go. So my right angle is U, T, and then this side would be V and S. Once I rotate the diagrams, it's much easier to see that my T, angle T, is congruent to angle G. And T is 103, the measure, and G is 2x minus 7 degrees, right? So if you can do the math, that should give me 110, so x should be 55 degrees. And if you use the same method, you can, and then if you just plug in x in the original angle, you would find the angle G is 2 times x minus 7, which is 103 degrees. And that proves that we did our math correctly. Third angle theorem is one of the most commonly used theorems. It says that in the 3 angles inside a triangle, if 2 of them are congruent to their corresponding pairs, then the third angle must be congruent to each other. Okay, let's look at this one. We need to find the angle measure for V. What we do know is, let's see, angle STU is congruent to angle VWU. Therefore, because angle STU's measure is 66 degrees, and angle, VWU is also 66 degrees. So we have 66 here. That's the first angle. I also need to know this angle, and that angle is easier because of the vertical angle theorem tells me that angle VUW is congruent to SUT. And since SUT, the angle measure is 44 degrees, my angle VUW is 44. And now if I use 180 minus 44 minus 66, I should have 70 degrees left here. So measure for angle V is 70 degrees. Okay? This is a proof. We have to prove that these 2 triangles are congruent. Notice what's given. 2 lines, 2 pairs of lines are congruent, 2 pairs of angles are congruent. What's not written down, but what's on the diagram, is that we have a common side. So let's see, we have to take care of that common side first. So let's write down what's given. The 2 lines, JH, are congruent. FG, JG are congruent. And so that's given. And because of those 2 lines are not because, these are given. And the third line, it's HG. And because it's reflective property tells us that HG is congruent to HG, so now I have 3 sides all taken care of, okay? And then the next one that's given are the angles. Angle JHG, these are congruent. FGH, angle JGH. So two sets of angles are congruent, and that's given. And let's see what happens to the third one. And obviously, if these 2 are congruent, by the third angle theorem, it says that angle F and angle J, angle J are also congruent. And this is third angle theorem. Okay, it makes sense, right? If you have 180 degrees for the three angles inside, you know two of them are congruent. The third pair obviously have to have the same angle measure. So we just proved that three angles are also congruent to their corresponding angles. And therefore we can draw the conclusion that triangle FGH is congruent to triangle JGH. Okay? Next one. In this one, we've got a midpoint at E that cuts off midpoint to both lines. Ooh, we like that. That means AE and EC are congruent. Oops. Let me write my wiggly congruent. And BE and DE are congruent to each other. And we are also given that AB and DC are congruent. We've got three sides, okay? And if we look for the angles, we know at least the vertical angles are congruent. So let's say angle AEB and angle DEC are vertical angles, and therefore they're congruent. We don't have information about the other two angles. However, we are given that on the side, I'm going to write it here, AB is parallel to DC. When I have two parallel lines, look at these two angles. They are alternate interior, right? So if I have angle EDC and angle ABE are alternate interior angles, and they should be congruent because the lines are parallel. And that's the theorem that we learned in the last unit. And for the same reason that these two angles should be congruent. So angle BAE and angle DCE are congruent because they're also alternate interior angles. And now I found all three pairs of angles are congruent. We can draw the conclusion that ABE is congruent to triangle CDE. That's my conclusion. Okay?